Hi everyone. In this video, we'll understand what is uniform flow and how to find the velocity of the uniform flow by using different formulas. So let me understand the uniform flow first. Okay. So you consider a channel which is having an bit slope. That is, slope of the channel is taken as I. The slope of the channel is I. Then this is the free surface of the channel. Okay. So this is the direction of the flow in the channel. See, usually whenever the water flows in the channel, there is an resistance will be offered by the channel bed in the opposite direction. Okay, this resistance, I'll take this resistance as F. This resistance F is counteracted by the component of the weight which is acting in the flow direction. So usually the weight of the water in the channel will be always acting vertically downwards. Since the channel is having a slope I, this angle of inclination is also becomes I. Okay. Now the component of this weight in the direction of flow is taken as weight multiplied by sine of I. So the flow becomes uniform. The flow becomes uniform only when there is a balance between this resistance F and the component of the gravitational force in the direction of flow is reached. There should be a balance between these two. Okay, but this magnitude of this resistance F, which is directly dependent on the velocity of flow V, provided all the physical factors of the channel like the depth and the roughness coefficient will be maintained constant, then the magnitude of this resistance F will be dependent on the velocity of flow. Okay, initially when the water enters the channel, this velocity and the resistance is very small when compared to the gravitational force. So this resistance as well as the velocity will gradually gradually increases and the flow becomes uniform, gradually increases and the flow becomes uniform when there is a balance between the resistance and the gravity forces reached. So in the uniform flow, in order to find this resistance means you have to find the velocity of flow. So finding the velocity of flow is very important in case of uniform flow. In order to find the velocity of flow V, to find the velocity of flow V, we have number of formulas will be developed. Then in that formulas, the most important are Chezy formulae and the Manning's formulae. So there are two formulas in order to find the velocity of flow, because this velocity of flow will be dependent, or this resistance is dependent upon was velocity of flow only. So in order to find the magnitude of this resistance means we need to find the magnitude of the velocity of flow. In order to find the magnitude of the velocity of flow, there are two important formulas are mainly or most commonly used. That is, one is Chezy formula, another one is Manning formula. Now we'll see how actually this Chezy formula is derived and what is the equation for the velocity of flow. How we derive the Chezy equation. So before deriving the Chezy equation, you'll make some assumptions. Okay, the following are the assumptions of the Chezy equation. The very first assumption is the flow is uniform. The flow should be uniform. The second assumption is pressure is hydrostatic in nature. So only the hydrostatic pressure is considered. The third assumption is depth of flow, velocity of flow, wetted area, and discharge are constant at any section along the flow. So all the parameters will kept constant as I told earlier. Then the next assumption is the total energy line, hydraulic gradient line, and the bed of the channel should be parallel to each other. These are the four assumptions made while deriving the Chezy equation. Now I'll write a sketch. So I'll consider an channel, okay, so which is having an slope I. The channel bed slope is I, the small I you can take. So this is the free surface of the water. Okay, this is the free surface of the water. So this will be where total energy line. So this is free surface, means in the open channel, this itself act as what? Hydraulic gradient line. So this is what? Total energy line. All these three lines are parallel to each other. This total energy line will make an angle. This total energy line will make an horizontal angle as I. That is small I is the slope of that one. This is the bed slope. Here, bed slope is I. That is small I. Okay, this is the direction of the flow of water. So this, since this is the direction, there will be what? The resistance force will be developed like this. I'll take the resistance force as F. Okay. Now what I'll do is I'll consider the two section. So one section here, the another section somewhere here. Okay. So I'll make this as A, this as B, this as C, this as what? D. So I'll take this portion only, A, B, C, D, where this V is the velocity of flow, F is the resistance. Okay. So the weight of this water in this A, B, C, D is taken as, weight is given by density multiplied by area multiplied by length L. So this I'll take it as length L, length of the channel between this two sections or between this A, B, C, D. Okay, so this is density gamma multiplied by area into L, means density multiplied by volume is nothing but the weight. The angle of inclination of this weight is nothing but small I. Okay, so if I consider the component of this weight along the direction of flow, as I discussed in the previous section, it becomes density, that is AL into what? Sine I. Okay, that is gamma AL into, gamma is density, AL is volume. Therefore, density multiplied by volume is nothing but weight, that multiplied by sine into I, because we have to resolve this component of this weight along the direction of flow. Okay, you understand? So now you have to, the Chezy has considered three forces. The very first force is the hydrostatic pressure force. The very first force is hydrostatic pressure force. As I discussed, only the pressure force, that is pressure, will be hydrostatic in nature. So if I take the hydrostatic forces, this will be my variation at this point. Okay, so hydrostatic force, this force I'll take it as F1. Similarly, at this phase of the another phase also, the hydrostatic force I take it as what? F2. That is F1 should be equal to what? F2. I have taken F1 and F2, two hydrostatic pressure force. Both are equal in nature, since all the factors we have kept constant. That is the main assumption of the Chezy equation. The second force is the weight, the component, that is the weight of water, which is nothing but what? Gravitational force. It's nothing but gravitational force, that is gamma AL sine I. The third and very important is the resistance offered for the flow. That resistance offered for the flow is, that is F, which is directly proportional to the wetted perimeter P, length of the channel L, and square of the velocity of the flow. This F is the resistance offered for the flow. Usually a frictional resistance will be developed, or any resistance which is directly proportional to the wetted perimeter P. So I have told about the wetted perimeter in the previous video. L is the length of the channel, length between these two sections, and the square of the velocity. If I remove this proportionality symbol, this, which is equal to, have to add one constant small f, becomes FPL V square. So the resistance which will be equal to what? Small f PL V square. This F is a constant which is added in order to remove this proportionality symbol. These are the three important forces that Chezy considered in order to derive the equation for velocity. One is hydrostatic pressure force, that is F1 and F2, both are equal. Then the gravitational force, nothing but weight of water in the flow direction, that is the density multiplied by volume into sine I. The third is the resistance. F is directly proportional to what? PL V square, that is F is equal to small f PL V square. Now we apply the Newton's second law of motion. What is Newton's second law of motion? That is F is equal to m into a. That is sum of all the forces, algebraic sum of all the forces in the flow direction should be equal to the mass multiplied by acceleration. Since the velocity is uniform or velocity is not changing throughout this length L, this acceleration becomes what? This acceleration becomes zero. Acceleration becomes zero because the velocity will not change throughout this length. Therefore, your algebraic sum of all the forces in the flow direction will be equated to what? Zero. Now, let me take this. That is F1 then plus gamma AL sine I. Rightward direction force are taken as positive, left one is negative, minus F2 minus this F is nothing but small f PL V square is equal to what? 0. Then these F1 and F2 are same, these two cancels, that becomes small f PL V square is equal to gamma AL into what? Sine I, where L and L cancel. For small values of bed slope I, small values means usually the bed slope is very small. The small values of bed slope I, this sine I will be equal to what? I. Therefore, this V square is equal to gamma into A into I divided by F into what? F into what? P. Then what is A by P here? You just remember the previous video where the ratio of the wetted area or the cross-sectional area of flow to the wetted perimeter is equal to what? Hydraulic mean radius, that is small m, or hydraulic mean depth, small m, that is A divided by P is equal to hydraulic mean depth, that is small m, or hydraulic radius also we can call it as. Then it becomes velocity V becomes square root of gamma by F into square root of, that is A by P is what? M, that is I. Okay. Here you observe carefully this. I write here the square root of gamma by F is taken as C, which is nothing but Chezys constant. This is Chezys constant. If I replace, I'll get V is equal to, that is root of gamma by F we have taken as a C, that is C into root of M into I. This is the formula in order to find the velocity of a flow in case of uniform flow in the channel. That is C is Chezys constant, that is M is hydraulic mean depth, that is A divided by P, I is bed slope of the channel. This is how you should derive the Chezys equation. Here, what happens is the velocity of flow equation for the Chezys is very simple, that is V is C into root of Mi. But in order to find this Chezys constant C is very difficult. So in order to find the Chezys constant C, number of scientists has given their formulas for the C. Okay, so in the next section, we'll look what are the different formulas which is available in order to find the constant Chezys constant C. Point C, we have a number of formulas that is to find C. We'll discuss one by one. to find C. The first and very important formula is Manning formula. That is Manning formula. The Manning formula is given by a scientist named Manning. That is given by V is equal to 1 by n into m to the power of 2 by 3, then I to the power of half, where n is called as Manning's constant. That depends upon the channel boundary surface. That is another one is m is hydraulic mean depth, then I is the bed slope of the channel. Now we compare these two equations. That is the velocity of flow equation of Chezy and the velocity of the flow equation for Manning. We can write if you compare these two, C is equal to 1 by n into m to the power of 1 by 6. This is how you can find the value of Chezy's constant C by using the Manning's constant n, that is C is equal to 1 by n into m to the power of 1 by 6. This is the first formula, that is Manning's formula. The second formula is Bézin formula or Bézin formula, call it as an the Bézin formula for the constant C is given by C is equal to 157.6 divided by 1.81 plus K divided by root m. These all are empirical formulas only. Okay, so no need to go through the derivations of this and all. Just remember the equation. So this C are the is important in case of Chezys equation. This C is found out by any one of the formula based on the data given in the problem, where K is called as Bézin's roughness constant or simply a roughness constant, that is K. M is hydraulic mean depth. Okay, this is the second formula, that is Bézin's formula. Then the third formula in order to find the value of C is Coulter formula. It is Coulter's formula or Coulter's equation, what we call. So this is somewhat a lengthy equation what we have for the Coulter. That is C is equal to 23 plus 0.00155 divided by I plus 1 divided by n whole divided by 1 plus 23 plus 0.00155 divided by I multiplied by n divided by root of m, where n is called as Coulter's constant. Okay, so here whatever I said, that is n is Coulter's constant or K is Bézin's roughness constant, n is Manning's constant, all these will be dependent upon the channel boundary surface. Okay, there is a table there, from that also you can find out the value of n. Later you substitute, get the value of C. Once you get the value of C, substitute in this Chezy equation, you get the velocity of flow. This is how usually we'll do. Sometimes the Chezy equation, that is constant, will be directly given in the problem. Once you find the velocity, the discharge of the channel, that is Q, is equal to area of the channel multiplied by what? Velocity. You get the discharge. Or you can also write Q is equal to A into that is velocity. I'll write C root of m. This to the discharge equation. So this is how in order to find the discharge, you should find the velocity. In order to find the velocity by using the Chezy equation, you need to find the constant, that is C. This C can be found out by using the three important formulas given by the three different scientists. One is Manning, another one is Bézin formula, another one is what? The Coulter formula. Okay, so this is how we should find out the velocity of flow in case of an uniform flow in an open channel. Okay, thank you all.